guys, welcome back. In this lesson, we are going to look at an interesting open source tool, Apache Sqoop. Let's say you work for a big financial institution and you started seeing some performance bottlenecks with your growing database. At the same time, your business users are expecting to perform historical data analysis on mass volume of data. Your ID group decided to invest in Hadoop. Now you have a Hadoop cluster up and running in your data center. Now what's next? The very first thing you would need in your Hadoop cluster is data, correct? Only then you can perform some meaningful analysis. If you start collecting data from scratch, it would take years, if not at least months, to have some meaningful data in your Hadoop cluster to perform some meaningful data analysis. Who has the time to wait for months and years, right? So, you look for existing data sources and right away you know that your existing database has all the key information that you can start with. And this is true for any company. There is no ID department in the world without a database. So a database is a good place to start from where you can get the data to populate your Hadoop cluster. And this is where Sqoop comes in. Sqoop is an open source tool designed to move data between structured databases and Hadoop. You can import data from a database like MySQL or Oracle into HDFS. And you can export data out of HDFS into database like MySQL or Oracle. In this lesson, we are going to see how we can use Sqoop to extract data from a MySQL table into a delimited text file and then put the file into HDFS. You can use Sqoop with any JDBC compliant database, meaning Sqoop can work with any database which has a supported JDBC driver. On all the major databases like MySQL, Oracle or SQL Server and even AS400 mainframe systems have JDBC support. In our lesson today, we are going to use MySQL database and MySQL is installed in our cluster. And here's a command to connect to MySQL. In our cluster, MySQL runs on this location right here, IP 172.31.45.216. And to log in, you give the username, which is training, and the password, which is again training. So copy this command and execute this in our cluster. And there you go. You're now logged into MySQL. Now we're going to use a database named training. So I'm going to switch to that database. So I'm going to say use training. The table we'll be using today is stocks. And here is the structure of the stocks table. It has symbol, name of the stock, the trade date, and closing price and volume of the stock for the given trading date. And finally, we have a timestamp column named updated_time, which records the date and time the record was updated. It is a regular MySQL table and there is nothing special about it. I have already created this table and I have already inserted some sample 10 records into this table. So let's go back to MySQL and say select star from stocks. And there you go. As you can see, this table has now 10 records. Now with Sqoop, we are going to extract this information from this table as a delimited text file and put the file into HDFS in a Hadoop cluster. If you're familiar with MySQL, you know that MySQL already has tools like MySQL dump to extract data from a table into a delimited text file. And you can find similar tools in other major databases as well. If that is the case, what is the need for Sqoop? Why don't we use the tools that come with the databases to extract the data? Can you guess why? With Sqoop, you can achieve parallelism with your extract. That is, you can leverage MapReduce and Hadoop framework to extract the data. When you run a Sqoop import command to extract data from a database table, Sqoop creates a map-only MapReduce job with multiple mappers. And each mapper extracts a portion of table and puts the contents directly into HDFS or even to a Hive table, which we'll see later. If your database is huge, this is a major advantage because with Sqoop, you now can have multiple mappers pulling the data at the same time. So it is highly efficient. In addition to that, you can also create Sqoop jobs to import data from your database in an incremental fashion. For example, you can create Sqoop jobs to import data every night into your Hadoop cluster. We'll see all that in this chapter. Let's now see few Sqoop import instructions to extract data from the stocks table. Here's the most simplest version of import. You can say Sqoop Import, and in the connect option, you simply supply the MySQL location with the database. And then you give the table name, and in our case, it is the stocks table. When you execute this instruction, Sqoop will connect to the database and it will run a MapReduce job and by default span 4 mappers. And each mapper will start pulling the data from the table. Now, let me ask you a question. How do you think the data will be distributed between the mappers? Or in other words, how does mapper 1, 2, 3, and 4 know which part of the data it has to pull from the table? Sqoop Import looks up for the primary key column in the table. In our stocks table, it is the ID column, which is an auto increment column, and you can see it has an incremental value. Sqoop does a min and max value on this column. So in our case, the min value would be 1 and max value would be 10. And with this information, the data is divided into 4 parts. For example, at runtime, Sqoop could decide records with ID greater than or equal to 1 and records with ID less than or equal to 4 will go to mapper 1. And records with ID greater than or equal to 7 and less than or equal to 10 will go to mapper 4. With that information, the mappers know the data boundary it is responsible for. The mappers will now work on its own portion of the data with no overlap between the other mappers. Okay, now that we understand how the import process works behind the scenes, let's execute our first import. So copy this instruction, go back to our cluster, but go to a brand new session and just paste the command, hit enter. Let's wait for the execution to complete and then let's review the output. The import process is now complete. Now if you look at the job counter here, you can see this import executed 4 mappers. And if you go up on top, you can also see here Sqoop executed a query to find the min and max values for the ID column in the table. And this is how Sqoop figured out the data boundary for each mappers. With this import process, the mappers extracted the data and by default the output will be stored in a directory with the same name as the table name at the user's home directory in HDFS. So let's now go ahead and check the output. So I'm going to say Hadoop fsls. The table name is stocks, so we can expect a directory named stocks in HDFS in the user's home directory. There you go. I see 4 files now, 1 for each mapper. So let's open up a file. Hadoop fscat. And I'm going to open this file right here. This mapper, that is mapper number 3, processed 2 records from the stocks table with ID 6 and ID 7. And as you can also see, all the column values are delimited by comma by default. That's great. And that is a very simple import. Let's say you have a very big table that you're trying to import into Hadoop. The 4 mappers that comes by default does not give you enough parallelism, so you would like to increase the number of mappers to 15. You can easily do that by using the -m option, as I'm highlighting right here. But before you decide on the number of mappers, have a word with your database administrator who is managing your database, because we know Hadoop can handle a lot of mappers at the same time. But we want to make sure that the database can handle the same amount of parallelism. We don't want to bring down the database, correct? Here in this instruction, since we have a small table, I'm going to reduce the number of mappers to 2, which means we'll end up with 2 files. Also here, with the target directory option, we are instructing Sqoop to put the output files in a specific user-defined location in HDFS. So let's run this import instruction now. The import is now running. So let's wait for it to complete and then let's review the output. The import is now complete. And as you can see in the counter, Sqoop did not execute 4 mappers by default, but it chose to execute the import process with 2 mappers because we have instructed Sqoop to execute only 2 mappers using the -m option in the import instruction. And also we specified the target directory to be Sqoop stocks and maps. So we can find the output of the import instruction on that location. So I'm going to copy this command. I'm going to do an ls on the target output directory. which is stocks_nmaps under Sqoop. There you go. I find two output files, one for each mapper. So let's open up an output file. So it looks like mapper 1 processed 5 records, which means mapper 2 would have processed 5 records again, because our table only has about 10 records. There you go. Now by default, the columns are delimited by comma. And what if you want the columns to be delimited by tab and each column to be surrounded by, let's say, quotes? You can use fields terminated by option to specify the delimiter and enclosed by option to specify the character to be used to surround each column. So here's the instruction for that. I'm going to copy this instruction and I'm going to execute it in our cluster now. So here in this instruction, Sqoop is going to delimit my columns with tab and enclose each column with double quotes. Let's wait for the execution to complete and then let's review the output. The job is now complete. Let's go to the output location and let's now open up a file. As you can see here, we have all 10 records in one mapper here because in our instruction, we have instructed Sqoop to use only one mapper using the -m option. And as you can see here, all the column values are delimited by a tab space and also surrounded by double quotes, exactly what we wanted. So far, we have imported all the columns from the table. But now let's say you would like to extract only selective columns from the table. And also you would like to export rows with ID greater than 5. You can use the column option in the import command to mention the list of columns and use the where option to specify the filter, which is essentially the where clause. So here in this instruction, using the columns option, I've specified 4 columns to import. And also with the where option, I've provided my where clause, which is ID greater than 5. So when I run this import, Sqoop will pull all the records from the stocks table with ID greater than 5 and will only import those 4 columns: symbol, name, trade date, and volume. So let's go ahead and run this import instruction. The job is now complete. Let's go ahead and review the output now. Let's first do a listing on the target directory in HDFS. There you go. We see the file from a mapper. So let's open up the file. And there you go. This import only brought in 5 records because we have added the filter ID greater than 5 and it did not bring all the columns into the file. It only brought in the listed 4 columns, which is the symbol, the name, the trade date, and the volume. As you can see, Sqoop is very easy to use. In this lesson, we saw what is Sqoop and its purpose and advantages. We also saw simple import instructions to import a table from MySQL database into HDFS. In the next lesson, we'll see some more custom import instructions and how we can use Sqoop to import files in different file formats. See you in the next lesson.